Okay, so today we're going to talk about solving rational inequalities. So let's talk about this example. We have 3 over x minus 4 is less than or equal to 2. And there's a few steps that we want to think about, and we can talk about what the steps are. They're really more kind of just guidelines. But the first thing you want to think about is to isolate 0. So you want to make sure that 0 is by itself, always that one first. Okay. And then next thing you want to think about is you want to talk about making it one fraction. So make it one fraction. And then the third thing you want to think about is you want to do, and I'm going to just write it on a short sentence, but there's a number line with test points. And I think really the best way to understand that is to just see me solve that example. So that's kind of just the general outline that we're following. And let's talk about this. So in this question, we have 3 over x minus 4 less than or equal to 2. First thing we want to do is isolate the 0. So I need to subtract 2 from both sides in order to get that 0 by itself. So that's what we're going to go ahead and do. I'm going to change this to a new page. I had 3 over x minus 4, and I now have minus 2 less than or equal to 0. I just brought that 2 to the other side. And then, of course, we need to make this one fraction. So that 2 I can think of as a 2 over 1, and I'm going to have an LCD. And you want to think about what that LCD is, and let's talk about that. In this case, the LCD would, in fact, be x minus 4. So we're going to have to multiply this the second fraction, top and bottom, by x minus 4. Sorry, that was a little tight squeeze there. And then here's the x minus 4, top and bottom. So we're, again, trying to make that a common denominator. So once we have that, we can go ahead and realize that now they have the same denominators, and that denominator is x minus 4. And then the numerators, I'm just going to write it down. Now some of you might want to think about distributing that in your head, but I'm first going to just write that down so we don't lose anything. Just exactly as it was written. So I have a 3 minus 2, and then parentheses, x minus 4. And then I'm going to go ahead and combine like terms. So I've got 3, and be careful when you're distributing, that is, of course, a negative 2 here, so be careful. 3 minus 2x now plus 8, still over the x minus 4, less than or equal to 0. We can go one more step to combine the like terms. You should be able to notice, which is kind of nice about these problems, but you should notice that those numerator has two terms that can combine. The 3 plus 8 will then give you the 11. So let's go ahead and do that on the next page. I'll have a negative 2x plus 11 over, and then my denominator is still the same as the x minus 4. And I still have the less than or equal to 0. Again, just going back and looking, I combined this 3 and this 8 right here. And that's where I got the 11 from, and the denominator stayed the same. Okay, once we get to that point, this is when we're going to do a number line. And we're going to break up our number line so that we can figure out where this fraction is positive and where this fraction is negative. So one thing you want to think about when you're dealing with this is, first of all, think about where this is undefined. So I kind of like to write myself a little bit of a note on the side. This fraction is undefined when x was 4, because you can realize that would then, of course, give me 0 on the bottom, which is no good. And the other thing I like to think about, and you want to kind of write this to the side so you don't forget, is where is this fraction equal to 0? So what I'm going to do there is, for this 0 part, I'm going to look at just the numerator of the fraction. So just this negative 2x plus 11. So let's do that actually on a new page. Negative 2x plus 11. I want to figure out when the top of that fraction is equal to 0. So kind of on the side, your scratch work, you do what it takes to solve for that. Sometimes they're easy to solve. Sometimes they're a little tricky. Whatever it takes, you can divide both sides by negative 2, and I ended up with x equals 11 halves, or if you wanted to write that as 5.5, whichever you'd like. So that was the other thing. So where this fraction is equal to 0 is at 5.5. So on our number line, going back to what we have for our number line, those are the two numbers that you're going to label. So I have a 4 and I have a 5.5, and I like to keep my labels undefined and 0, and you're going to see why in a minute, so that we can figure out a little bit more of a tricky problem about these interval notation that we're going to have to do. So once we have this labeled, I've got my 4 and my 5.5. You're going to now pick test points. Okay, so what we're going to do with these test points is pick some numbers in all portions of your number line, because we've now broken up our number line. So something to the left side of 4. You can pick 1, you can pick 2, you can pick 0, you can pick -3. Anything that's something to the left of 4. And then in between 4 and 5.5, I'm just going to pick 4.5. And you can do any number of things. You could have picked 5 if you feel like that maybe is easier. Maybe 5 would be easier. And then something to the right of 5.5, I'm going to pick 6. And what I'm doing with those numbers is I'm actually plugging it in into once we had our 0 by itself and its one fraction. So you're plugging it in to see what you get. So let's plug in 0. 0 is the first one. -2 times 0 plus 11 all over 0 minus 4. And what are we going to get? That's going to end up with 11 divided by -4. Now, I don't actually really care so much about what the final answer is. What I cared about was the fact that it was negative. Because now that it's negative, we realize that portion of the number line is negative. Let's do the same thing for the next portion of the number line. Let's now plug in 5. So -2 times 5 plus 11 over 5 minus 4, and this will become -2 plus, or sorry, -10 plus 11, which is 1, and then 5 minus 4 is 1. Turns out that that was positive, so that makes that whole portion of our number line positive. Oops. Okay, and then again, we're going to do the same thing for that last portion of the number line. I have a 6, so let's do -2 times 6 plus 11 all over 6 minus 4, and you ended up with -12 plus 11, which is -1. 6 minus 4 is 2, and again, we didn't care so much about what the number was. We just cared that it was negative. So that gave us those number lines, what I was talking about at the beginning of this video, that number line with test points, and that's what that is right there. So let's think about what that represents now. We're done with all the work. We just need to write down the answer. And you go back to what the question is asking for. As you'll notice, and you got to be really careful to make sure you're noticing this, but as you'll notice, the original question had a less than or equal to. So we're looking at that less than or equal to. You almost want to really hone in on that's a less than, meaning negative. Okay, so we're looking for the negative portion. So because it was that, we're looking for those two portions. How do we write that in interval notation? Well, the first negative portion of our number line was from -infinity to 4. And be careful, undefined. Undefined, you keep it in open parentheses. We can never include an undefined, so that's an open parentheses. Union, and then we now have a 5.5 to infinity. That was the next portion of my number line. That was negative. Now I have an equal sign. So this is a less than or equal to, which means I can, in fact, include the 0. So that's going to be the closed parenthesis. You can never include undefined, but you can include the zeros if you have that line underneath our inequality that's asking for. And that would be our interval notation for the solution to this problem. Ta-da!